Hello, this video is on the normal distribution. Specifically looking at normal probability calculations and inverse normal calculations, as shown here in the syllabus. With all these questions, it's best to sketch a bell-shaped curve first. Label the x-axis and identify the mean. The mean is 40, so place 40 in the center. Next, add a scale by using the standard deviation. The standard deviation is 10. Remembering that 3 standard deviations will take you almost to the top and to the bottom of the distribution. So add 3 tens above and subtract 3 tens below. Next, identify the area required. Draw a vertical line at x equals 37 and another one at x equals 48 and shade the area in between as shown. To find the required probability, we need to use our calculators, and I'll just show you how to do that. So from the menu, choose option 2 for statistics. Press F5 for a distribution and F1 for a normal distribution, and F2 to do a normative cumulative probability calculation. Make sure that the data is set to variable, and then scroll down and set the lower limit to 37, the upper limit to 48, the standard deviation to 10, and the mean to 40. Then pressing execute will display the required probability. So the probability that x is between 37 and 48 is 0.406. In part B, again start by sketching a bell-shaped curve, labeling the axes as before. To identify the area required, draw a vertical line at 26 and shade the area to the left. To find the required probability, since the curve continues infinitely to the left, we need to set a low value for the lower limits, and the upper limit will be 26. So on the calculator, we press exit, scroll up, and set the lower limits to a small value. So 1 times 10 to the power of negative 99, and the upper limit to 26, and then press execute. So the probability that x is less than 26 is equal to 0.081. For part C, again start by sketching a bell-shaped curve and labeling the axes as before. To identify the area this time, draw a line at x equals 45 and shade the area to the right. To find the required probability, set the lower limit to 45 and the upper to a large number. So press exit, scroll back to lower limit, enter 45, and for the upper, I'll enter 1 times 10 to the power of 99. Pressing execute will display the required probability. So the probability that x is greater than 45 is 0.309. You may be given a particular probability and asked to work backwards to find the corresponding value of x. And this can be done directly on your calculator. And again, because you're working backwards, we have to use the inverse normal function. So in this example, we're given a normal distribution and we're told the probability of x being bigger than a value a is equal to 0.05, and we need to work backwards to find what the value of a was. So on our calculators, press exit twice, back to the main menu, press F5 for a distribution, F1 for a normal distribution, but this time press F3 for an inverse normal calculation, and make sure the data is then set to variable. So the area to the right of A is equal to 0.05, so we need to set the tail to right on our calculator. If we scroll down and pick F2 to select right, and scroll down again and set the area to 0.05. Then if we enter the standard deviation as 4.5 and the mean as 92 and press execute, the value of x, in this case a, will be displayed. So a is equal to 99.4. To find k in this question, we can start by stating the distribution. We're told the shell lengths are normally distributed with a mean of 70, so we put 70 first, and a standard deviation of 10, so we put the variance 10 squared second. Next, sketch a bell-shaped curve, and then put the mean 70 in the central position. Then use the standard deviation of 10 to add a scale, adding 3 tens to the right and subtracting 3 tens to the left. Next, identify the probability, in other words the area, given. And we were told the probability of x being less than k is equal to 0.95, 95%. And since that value is bigger than 0.5, bigger than half, it makes sense that k must be on the right-hand side of the diagram. So since we're finding an x value, we need to use the inverse normal function on the calculator, and the tail needs to be set to left. So on the calculator, if I press exit and I scroll up, again make sure data is set to variable, and press F1 to select a left tail. Then if I scroll down and set the area to equal 0.95, the standard deviation to equal 10, and the mean to equal 70. And then press and execute will give the corresponding value of x, or the value of k in other words. So k is equal to 86.4, which means that the 95th percentile corresponds to a shell length of 86.4 millimeters. In this final question, we're asked to calculate the interquartile range of a trip. We're told the train times are normally distributed, so if we start by stating the distribution. If we convert the average train time, 2 hours 15 minutes, into minutes, the distribution will be that x follows a normal distribution with a mean of 135 and a variance of 4 squared. If we next sketch a symmetrical bell-shaped curve, labeling the x-axis and put in the mean time 135 in the center. Next, if we add a scale by using the standard deviation of 4, by adding 3 multiples of 4 above 135 and subtracting 3 multiples of 4 below. Remember also the interquartile range is the middle 50%. And because the normal curve is symmetrical, that means 25% below the mean and 25% above the mean. So to find the interquartile range, we need to find Q1 and Q3. And since these are values of x, we need to use the inverse normal function again. This time, as the probability given is a central 50%, we need to set the tail to central. So on the calculator, press exit, scroll up, make sure data is set to variable, and press F3 for central. And scroll down and set the area to equal 0.5, standard deviation to equal 4, and the mean to equal 135. Press and execute will display the two values of x. So the lower quartile Q1 is 132.3 and the upper quartile Q3 is 137.7. Finally, to calculate the interquartile range, we subtract Q1 from Q3. So the interquartile range of a trip on these trains is 5.40 minutes.